Alright guys, we're going to move on to the surface area of prisms. So, prisms that are not rectangular prisms, they're a little different. So in my example, when I folded up the figure that we found the composite area of, this was an example of a triangular prism. So a prism, by definition, it is, according to our notes on classifying three-dimensional figures, it is a solid with two bases that are congruent and parallel. Okay, so these bases aren't really parallel. Parallel means that they're exactly opposite of each other when it's like a flat shape like this. So notice that this triangle part is parallel or exactly on the opposite side of this triangle part, and they're the exact same size. So by definition, this is a triangular prism because the base, the parts that are opposite of each other, they are triangles. So that's the type of prism it is. So usually with prisms, you end up having two shapes that are opposite of each other and are exactly the same measurement, and then everything in between connecting it, they're going to end up being rectangles. So that's easy to kind of identify a prism when there are rectangular sides with two bases that are different shapes, okay, and opposite of each other. Those are prisms. So this is an example of a triangular prism, okay, and it's important to identify the base because that's a huge part of our surface area formula. Okay, so remember the base is the part that's not triangular or that's not rectangular. They're the shapes that are opposite of each other or parallel and congruent, the exact same size. Okay, remember we found that this was 14 centimeters squared and that was 14 centimeters squared. So I'm going to look at this example problem. I'm going to look at this figure. So by looking at this, I see, okay, this is a rectangular side. I look at the back side, that's kind of in the background with these dotted lines. That's also kind of rectangular, and then the part behind it is also rectangular. The only thing I see that's exactly opposite of each other is this top part. Okay, it matches exactly this bottom part right here. And the shapes that I see are triangles, okay? So these are two triangles that are opposite of each other, but they are the exact same size. Hence, it being a triangular prism, another example of a triangular prism. So in our formula, it tells us that the surface area is equal to the height between the bases. So the height, so if these two triangles are the bases, it's the height between them, right? The distance between them. So in this case, it's 16 feet. So not only the height of the figure, specifically the height between the bases. I'm going to put between bases. Okay, then I have P. P is the perimeter of the base. So perimeter is, I just take the length of all the sides of the base and I add them together. Okay, so P stands for perimeter of base. We just need to use one of the bases for that. And then this big capital B is the area of the base. So we just take one of the bases and we find the area. Okay, area of base. Let's do this one at a time, kind of plugging things into our formula. So the surface area of a prism, specifically this triangular prism, is equal to the height between the bases. So I look at the distance between those bases. That tells me it's 16 meters. So I'm going to put 16 for that one. Then it wants me to find the perimeter of the base. So these two are exactly the same. Those are our bases. So I'm just going to add the length around this base. In other words, if I were to take a string and just wrap it around the top of the shape, how long would that string be? So I'm just going to add them. So I just need to do 9 meters plus 12 meters plus this part, which doesn't label it here, but it does label it here. It says 15. So I'm just going to put that in parentheses, 9 plus 12 plus 15. Okay, that is the perimeter of my base. I just add up all the sides of that base. Okay, then I add it. Again, I don't have room over here, so I'm just going to put it under. I add it to 2 times the area of my base, okay? The area, so my base is a triangle, so I need to use the triangle area formula. This is a lot of things put together, okay? So if you guys remember, the area of a triangle is 1/2 of the base of the triangle times the height of the triangle. So remember, the base and the height have to be perpendicular, and it so happens that it labeled that I have a right angle. That means that it's perpendicular. So the height of this triangle is 9 meters and the base is 12 meters. The base and the height are perpendicular from one another, so I could use those as a label. So 1/2 times the height times 9 times 12 times the base. That is how I find the surface area of a triangular prism. That's my shortcut formula, which kind of takes a long time, but it's still my shortcut formula. Another thing you could do, like we did with this, if the formula really confuses you, is just find the area of each individual side and add them all together. It might be hard to picture when it's a 3-dimensional shape like this, and it might be hard to cover all your sides. So the formula at least guarantees that you include everything. Okay, so I'm just gonna plug this into my formula and see what I get. So that gives me 16 times 36 if I add them all together, plus 2 times 54 if I add them all together. 576 plus 108, and that equals 684 meters squared. Okay, so that's my answer. That is the surface area of this triangular prism. Remember, the most important thing you have to do first is identify what's the base of the prism. Okay, in this case, it's a triangle, but there are other shapes. There are rectangular prisms, there are triangular prisms, there are trapezoidal prisms, and things like that. So make sure that you identify that face first, the base of it. And if you have any questions, I have office hours every Tuesday, Thursday, from 1 to 2, so please log on to my office hours and ask questions. We can do more example problems together.